Hey everyone, welcome to the fourth video in our series on the reactions of chapter 9. So in this video, we're going to be talking about addition of halogens to alkynes. All right, so again, we had the addition of halogens reaction to alkenes. In this case, we're going to be doing addition of halogens to alkynes. So this is addition of halogens to alkynes. All right. So whenever we do this with alkynes, okay, the main thing that we need to know is that this is anti-addition. All right, so just like the reaction with alkenes, reaction of alkenes was anti-addition, this one is also anti-addition. All right, and we'll see that in a second, okay? This is going to be pretty brief. There's not a lot going on with this. We'll talk about the mechanism quickly, and then we'll be done with this reaction. All right. Okay, so let's take a look at this with this internal alkyne here. So internal symmetrical alkyne, and then we just add like Cl2, Br2, something like that. So I'll use Cl2. And we usually use CCl4 as our solvent, okay? And the only thing that I need to say with this is whether or not I'm using one or two equivalents. All right, so let me actually get rid of this, and then I'll say that I'm going to be using one equivalent of Cl2. So one equivalent of Cl2 is just going to add one Cl2 across this and get rid of one of the pi bonds. So that's going to give me this. You'll notice that the Cl's are on opposite sides because it has to be trans because it's anti-addition. All right. So it will always be trans whenever it can be. All right. So this is one equivalent of Cl2. However, if I add two equivalents of Cl2, and CCl4, then what happens is I just add two Cl's to each carbon. So I have two chlorines here, and I have two chlorines here. All right. And that's it. Okay. That is as difficult as this reaction gets. Okay. I promise. So again, this works with Br2. So let's take a look at a different alkene here. So we'll take a look at this alkene. So if we do one equivalent of Br2 in CCl4, then this is 1, 2, 3, 4, 5, 6, 7 carbons long. So 1, 2, 3, 4, 5, 6, 7, sorry. Then all we do is we draw the double bond on carbon 3, right? So 1, 2, 3. And then we just make sure that the bromines are trans. So bromines are trans from each other. And that's it. Okay. And then, if we did the same thing, but we added two equivalents instead, then that would be no problem. All that happens with two equivalents would be that we add two bromines to each carbon. All right. So again, on carbon 3, or actually not on carbon 3, sorry. I don't have the double bond anymore, right? I got rid of both the pi bonds. So bromine, bromine, and bromine and bromine. That's it. Okay. So this is my entire reaction. All right. Does not get any more complicated than this, even if I have a terminal alkyne or something like that. So let's put this through with a terminal alkyne just to see it. We'll use one equivalent, CCl4. And all this is going to do is just add two chlorines. So Cl and Cl. That's it. And then if I used the same thing, but with two equivalents, then I would just add two chlorines on each one. That's it. Okay. So like I said, this is as difficult as this reaction is ever going to get. So if you understand this, then you're totally solid. The only other thing we'll do is we're going to talk about the mechanism. But the mechanism with this and the mechanism with addition of halogens and alkenes is almost completely identical. All right. So let's take a look at the mechanism with this alkene. And we're going to do two equivalents of Br2 in CCl4. And again, we know what this makes. It just puts two bromines on each carbon. All right. Okay. So now let's take a look at how this happens. So again, just like what would happen with the alkene reaction, all right, I have my two bromines here. And these are going to get attacked by one of the pi bonds. All right, so the pi bond is going to attack one of these bromines. This bromine is going to leave. And then this bromine is going to attack back. Okay. And then what that's going to do is it's going to form the three-membered ring structure. Okay. Except I just have an extra bond. That's basically the only difference with this mechanism is everything is the same except I have an extra bond the entire time. Okay. That's the mechanism basically. So again, this has two lone pairs and the bromine. Okay. And it's positively charged, right? And then we also get Br minus here. So this Br minus, what this Br minus is going to do is the Br minus is going to come in. It's going to attack one of these carbons. And this bromine's going to leave. So then that's how I isolate my trans alkene here. So then I have my trans alkene. All right. And if I was just using one equivalent, then this would be the end of my mechanism. All right, that would be the whole mechanism. But in this case, I'm using two equivalents. So the same thing, you guessed it, just happens again. All right, that's all that's going to happen. So I just do the same thing again. So this attacks, and at the same time it gets attacked, and the bromine leaves. And again, I form my three-membered ring. The only difference here is that the methyl groups are going to stay trans, and the other groups are also going to stay trans. So the two bromines are going to stay trans. Same thing with the methyl groups, right? And then I have my three-membered ring with bromine positively charged with two lone pairs on it, okay? And then all that's going to happen is the other bromine is going to come in and attack, and I'm done. So it attacks there, and I am done. That gives me my product. That's it. So again, it's basically just the same mechanism that just happens two times in a row. And it's the exact same as the addition of halogens to alkenes. All right. Only difference is I just have one more bond. It just happens twice. Okay. So that's all I'm going to say for this reaction. I hope this video was helpful, and I will see you in the next one.